Hello, welcome back to Mrs. Ogram's Maths. This video is going to take you through the worked solutions for the probability external for level 2 maths that was in 2020. So it's achievement standard 91267. This one is about electric vehicles, which is EV for short. Pause to read the question. Now we've got some space down here to try and represent this as a diagram. I think this one probably lends itself towards a tree diagram. First of all, we can split them into being staff or students. So we've got 15% was staff, and so the rest would be students, making that 85%. 90% of the staff drove, so 0.9, and 43% of the students. Of the students who drove, 36% said they wanted an EV, so that's 0.36. And 60% of the students who did not drive, said they would like to own an EV, so want an EV. 0.6. So I'll just fill in this one here to make that up to 1. That would be 5, 8. Okay, now part A, find the probability that a randomly chosen respondent in the survey is a staff member who drove. So we're looking at this branch here. Oops, 0.9. We get 0.135. For part 2, find the probability that a randomly chosen respondent in the survey is a student who did not drive to the university and would not like to own an EV. So they don't want an EV. So I've just added those branches of don't down there. So we want students. I'm just going to highlight all the bits that we want in our thing that we're looking at. So let's go with, they need to be a student who did not drive and would not like to own an EV. So we've got 0.85, 0.58 and 0.4 as we go along that branch there. Just realized I made a mistake. That's not 58 there, that's 57. So that we'll just fix that up like so. Okay, if a student said that they would like to own an EV, what is the probability that they drove? So let's write down what that is. The probability that they drove, if we already know it's a student who wants an EV. So this is a conditional probability. So what we do with conditional probability is that we restrict our view to only consider the condition that has been applied at the beginning. So a student that wants to own an EV is our condition. We're only considering those students. So the probability of getting a student that wants an EV. So now that we've restricted our universe down to only looking at those ones, within that group, what's the chance that they fit this other condition? So we want the probability that the student drove and they're in this group. So, and they want an EV. Okay, so let's go back and look at our tree diagram. So if they drove and they want an EV, that was this line here. So 0.85, 0.43, 0.06, 0.85, 0.43, 0.36. So satisfying all three of those things. Now we'll put that over the probability of getting a student that wants an EV. So we've just worked out the branch for the ones that drove and want an EV. We also need the students that didn't drive and want an EV. So that'll be 0.85 times 0.57 times 0.6. And we'll add it to what we had previously for the other branch to make the total of all the students that want EVs. So the top is 0.13158. The bottom is 0.4228. So doing that division, it's 0.3116. Okay, now we're going to get some more information about the staff that drove. 52% want to own an EV. A quarter of the staff that didn't drive want an EV. So let's add that to our tree diagram. And then the question asked for the proportion of all people that want an EV. So now we can add in this other branch that we've already got the students that want an EV from the previous question, but we now need staff that drove and want an EV, and also staff that did not drive and want an EV. So we'll add those branches in as well. So that would be 0.15 times 0.9 times 0.52. And we'll add on 0.15 times 0.1 times 0.25. So that total will give us the proportion from the staff. The students we already worked out in the previous question. So the total students that want an EV was this one, 0.4228. So if we add them up, we've got 0.49675, and the question asks for percentage. So we need to just turn that quickly into a percentage, 49.9%. Oh wait, rounded wrong, 49.7%. And my apologies, in checking the answers, I realized I made a small transcription error. I missed a 2 in writing this down here, so this is 0.42228. Doesn't actually make a difference to this answer over here. It makes a slight difference to this one. So this one, students, I've added in the 2 there and adjusted the answer here. You can see what I've done over there on the calculator, and our final percentage is 49.6. Okay, for part B, we're looking at the likelihood of whether they live close or not, and then whether they want to own EV or not. We've got quite a lot going on in this question, and we need to end up with finding out how much more likely it is for a randomly chosen respondent who lives close to want to own an EV compared to those that do not live close. So let's start by working out what we would need to be able to calculate this. So we want to compare the probability that they want to own an EV if they live close, and compare it to the probability that they want to own an EV if they don't live close. So it helps to know what we're aiming for, and now we'll get on with trying to fill in as much of the tree diagram as we can. So let's start with the easy parts. This will be 0.6, this will be 0.28, and then I'll add some more branches. So what we will need for if they want an EV and they're close, we need the staff close and want an EV, and the student close and want an EV will give us this one here, the probability they want an EV. If they're close, we'll need those ones. Then for the ones that want an EV but aren't close, we'd be looking at staff not close, want an EV, and student not close, want an EV. So we're missing some details on those branches. Let's see if we can fill them in from what we've been told. Okay, so this is the paragraph that's going to help us out here. We don't have exact numbers, but we do know that they're twice as likely to want to own an EV if they live close, and that's for both groups of people, staff and students. So whatever's on this branch here will be twice as big as what's on this branch here. So if we call this branch x, this one can be 2x. And similarly for the students, whatever's on this branch is going to be doubled to make this branch, but it's not necessarily the same as what was on these branches. So we need another variable there. That can be y, and this can be 2y. Okay, let's look at the last bit of information that is just down here. Overall, 49% of the staff and 43% of the students would like an EV. Okay, so let's use the staff one first. So looking up here on the staff bit, after we sort of pass that line of staff, we will then look at the branches where they'll want an EV. So close and want an EV, not close and want an EV, those bits will make 49%. So if we consider the staff first, want EV would be 0.4 times 2x and 0.6 times x, and it's equal to 0.49. So x is 0.35. Let's do the same thing for the students. Okay, so after we're already at the point of it being a student, the want EV line this way and the want EV line this way will make 43%. So 0.72 times 2y, 0.28 times y will make 0.43. So y is 0.25. Okay, now we've got enough information to work out the probability they want an EV for the ones that are living close. Actually, I should have done that as this sort of symbol instead of the line. So that's going to be staff want an EV living close and students want an EV living close. So if we go to the staff line, it's 0.15 times 0.4 times, now the 2x is going to be 2 times, the x was 0.35. Okay, so we've got the staff section covered there, and now let's add in the students. So 0.85 times 0.72 times 2 times y. Y was 0.25. So the chance of the ones living close and wanting an EV is 0.348. Let's do a similar thing for the not close. And we get 0.091. Now we want to make a comparison between those two. So how much more likely is it for the close ones to want the EV than the not close ones? That's 3.8 times bigger. So 3.8 times as likely to want an EV if they live close compared to if they don't. Well done if you followed through that. That was quite a long and tricky one. Right, on to question 2. And here we are looking at a normal distribution. So we've got a normal distribution happening with a mean of 165 and a standard deviation of 14. So the probability that we'll travel between 150 and 165. We're going to just use our graphics calculator. So here's a reminder of how to do that. Go to Menu, Stats, we want Distributions, and then Normal. And we are doing cumulative all the time for just a straightforward workout probability. Never touch this NPD one, you're not going to need that. So it's always cumulative unless we're working out an inverse, so working backwards from a probability. So we're just working out probability on this one, we want F2. Okay, so our lower limit is 150. The upper limit is 165. Sigma is 14. And the mean is 165. So we get our probability is 0.3580. Okay, same setup for this one, but probability more than 162. Oh, sorry, 172. And on the same diagram here, oh, I should have filled in with this 165 one, we were doing from 150 up to 165. That's what the diagram looks like. Now for the 172, we've got 172 here, and we want more than. So the probability of it being more than 172. Okay, so back to here. This time our lower limit is 172, and our upper limit is just something very, very big, because the normal distribution carries on infinitely towards that right-hand tail. We haven't changed sigma or the mean, so now we can put that in and we get 0.3085. Okay, 10% of the time Jeff is not satisfied for how far one full battery charge would take him. So for him to be satisfied, what's the minimum distance his car will have to travel? So we're looking at 10% of the time where it doesn't go as far as he would like it to. So we're talking about his shortest 10% of journeys, and we're trying to work out this value where 10% of them were too short, so he wouldn't be happy with them. So we're working out the probability that x is less than some number. I won't call that x, actually, we'll call that s for satisfied. Okay, so x is less than s would equal 10%, 0.1. So this one, if we come back out to our distributions menu, normal, this time we are using that inverse normal because we're starting with a probability and working out the value that created it. So inverse normal, we've got our tail is on the left, the area created is 0.1, the sigma is still 14, and the mean is 165 because that hasn't changed in the question. So 147.06 will give us that 10% value. And we'll just put that into words. So Jeff will be satisfied if the EV goes at least 147.1 kilometers. Okay, now for this second type of one, we've got second generation EV. On this one, 20% of the distances travelled on a full battery charge were less than 265. So we've got our normal distribution. We've been told in this section that the standard deviation has remained the same. We've got the lower 20% goes less than 265. We want to calculate what the mean would be. So what is the mean of that distribution here? The mean I will refer to as mu. Now to do these questions, we use what's called the standardized normal curve. So this is your x curve over here, everything that's happening on your x values. What I'm going to set up is the z curve that we know those basic probabilities of, and everything else gets calculated from them. On the z curve, the mean is 0 and the standard deviation is 1. Now what we can do is work out where that 0.2 would be on the z curve. So if we had that area set up, let's just go to normal and then inverse what value would give us that 0.2. So we've got an area of 0.2. The sigma is 1 and the mean was 0. So on the z curve, this value happens at negative 0.8416. Now on your formula sheet, you've got a whole table of values that you can read off to do that, but we use the calculator. What is helpful on that table of values is that right at the top of the page, it tells you that z equals x minus mu over sigma. That tells us how to convert between these two. So if we know where something's happening on the z curve, we can figure out the matching parts on the x curve. So that value of z was minus 0.8416 for a matching picture of z. The x value that matches that same picture is 265. The mean we don't know, we're trying to work that out, but sigma was 14. Okay, so now if we use equation solver or rearrange that, we can work out that the mean is equal to 276.8 kilometers. Part C, we've got the results of some test drives that were done on this second generation EV. And the car manufacturers claimed that the second generation one can travel 280 kilometers on one charge on average, and that those distances would be normally distributed with a standard deviation of 14. We're asked to make some comparisons so we can decide if they're making a valid claim or not. Okay, so let's start by working out what the mean and the standard deviation is on here. Now, what we'll do to do that is use our stats menu, and we'll put the median of each of the bars and then their height for the frequency into our table here. So this first one would be 225, next one would be 235, and so on. And then list 2 is all of the frequencies. So we've got 1 for the first bar, 2 for the height of the second bar, and so on. I'm going to fill those in. So now the calculator can work out a lot of stuff for us. So if we go to calculations that we want to do, we first of all need to check the settings because your calculator would have been reset for the exam. And we tell it that our variable is in list 1. Now the default is to have the frequency as just 1 per variable, but we've actually just put the frequency in. We put it into list number 2. Okay, so we've got variable in list 1, the value along the x-axis, and then the frequencies went into list 2. Okay, so we've set the settings. Now we are wanting to do some calculations based on one variable. Although we've got 2 columns, it's one variable that we're measuring, just the amount of distances that these batteries achieved. So one variable. Now we get a whole bunch of stuff. The thing we're looking for is the X bar. So that's 278.3. I'm going to write these down. So we've got the mean of 278.3 kilometers. The standard deviation is this value here with that little sigma. So 20.4. Okay, now let's do some comparisons. So since they've asked us to compare shape, center, and spread, let's do each of them and clearly sort of signpost when we're doing them. So shape. Well, quite obviously, this is not a nice symmetrical bell curve, so we'll write something about the shape there not quite being normal. Next, let's look at center. So the mean on the histogram we worked out was 278.3, which is close to what's being claimed at 280 here. Okay, next is spread. So the standard deviation we worked out from the histogram was 20.4, and that's quite different to the 14 that was suggested for the normal distribution. So the last thing left to do is to evaluate the claim. Now, of those 3 characteristics we looked at, only one of them was really close. So I'm going to go with normal distribution not being a particularly good representation. Right, and I've just checked the answers. I just want to mention one thing about spread. It wasn't necessary to work out the 20.4 exactly from the table of values. You can do that by looking at the graph and estimating what it should be. So the range there is 220 to 320. That's 100. Now the standard deviation, if it was going to follow a normal distribution, that range would cover 6 standard deviations. So you could have also suggested as a simplification of that this could be the standard deviation. It still doesn't match the 14 that was given here. Okay, let's move on to question 3. Okay, so we've got this table of information. What proportion of survey respondents owned an EV or a PHEV? Okay, so we want the total of EV or PHEV out of the total respondents. That comes to 0.21. Which type of vehicle owner is more likely to have a home solar system? So we need to compare the chances of having a solar system for each of them. So the chance of having solar if they are an EV owner. So we look only at the EV owners. We've got 104 out of 275. and then the probability of solar if they are PHEV is 45 out of 145. So 0.3103, and the probability of solar if they are non-electric. So the non-electric vehicles, we've got 205 out of 1580. So EV owners had the highest number there. All right, next question. Okay, so the proportion of those that had the home solar system and also had EVs from table 1. So of the home solar systems that had EVs, it's 104 out of 354. Then we multiply that by 22144. It rounds to 6. So then part 2 is a reason why that's not a valid estimate. The most obvious one is we've taken information from the US and applied it to New Zealand. Okay, nice easy one to start us off on the next bit, which is fill in the gaps. And if you're not sure how I'm getting each number, you can just look across to the calculator. Now we want the probability that a randomly selected respondent whose vehicle was non-electric then had a home solar system. So of the non-electric vehicles, the chance of having a home solar system is 185 out of 879. Okay, part 2. We've got some comparisons between, so this one's table for North America. This one here was the table for Europe. Looks like we're going to do some comparisons here. Okay, so can the claims be supported? Let's check out what the claims are. So the claim is that in North America, EV owners are 3 times as likely to have home solar systems as non-electric vehicle owners. Let's test that one first. So having a home solar system, given that they are an EV owner, so that's 104 out of 275. Compared to those that were non-electric vehicle owners, so that's 205 out of 1580. And then we'll compare those likelihoods. So 104 over 275 divided by 205 over 1580 comes to 2.91. And I'll just put the words that go with that. So 2.9 times as likely. This value here is nearly 3 times bigger than that one. Okay, so let's check what that claim was. In North America, they're 3 times as likely. Yep, that claim stands. It's very close to 3. Now let's look at the other claim. That was that in Europe, EV owners are only 30% more likely to have a home solar system than non-electric vehicle owners. So let's do the same things that we just did here, but for Europe. I've actually just copied and pasted that and left some gaps to fill in. So home solar if they have EV in Europe. So let's look at that table. So that'll be 63 out of 225. And then on the non-electric Europe table, we've got 185 out of 879. And we'll do our comparison. And we get 1.33 times as likely. Now let's take a look at the claim that was made for Europe again. So 30% more likely. Well, 1.33 is 33% more likely, so that again is quite close. So I'm going to make the call that both of those claims were justified.